We're going to continue talking about acids and bases. This time we're going to talk about equilibrium in acid-base reactions. So let's write a generic example. So this is your acid HA, and it is in water. And this double arrow, remember, represents equilibrium. But later on, we're going to talk about the position of the equilibrium. But right now, we're not going to worry about that. Here, that's my acid. So I'm going to write here my conjugate base, and I am forming also hydronium. So here, labeling, let's do that. So acid, base, conjugate acid. Those are my labels right there. Now we're going to define here, remembering, this is remembering your Gen Chem. So we're going to write the equilibrium constant for these reactions. So my equilibrium constant, we write here the product of the concentration of these two species, which are the A negative times the concentration of hydronium over the concentration of the acid times the concentration of water. But now we can redefine that if we think the concentration of water doesn't change much. So we can group, we can make, say, a new constant, and we can define Ka as the product of the concentration of water times the equilibrium constant. And we can find that doing rearrangement of these equations that we can write now, Ka as, so regrouping and using that definition, Ka equals the concentration of A times the concentration of hydronium over the concentration of the acid. So let's think about what is the meaning of this equation. So if we think of this equilibrium in this equation, if the acid is very strong and it produces a lot of the conjugate base and hydronium, then this is going to be big compared to HA. So in other words, if Ka is greater than 1, meaning the number above is greater than the number below, this is an equilibrium that is favored the product favor. So we will have more of the products than we have the reactants. On the other hand, if the acid is weak and we have more of these species at the equilibrium than we have that, then we will have that this number is bigger. If this number is bigger than the number above, then Ka is going to be smaller than 1. Ka is smaller than 1, again, will mean this number is bigger, so this is reactant favor. So meaning that we have more, again, K1 greater than 1 is product favor. And here, Ka smaller than 1 is reactant favored. That's my reactant side, my product side. But what if the Ka is about 1? So in that case, we will have about the same concentration of these two species than we have the acid. So that is an equilibrium. So it's neither product favor or reactant favor. That's actually an equilibrium. So we're going to use that. And in actually reactions. Another definition that we need to make here is pKa. And pKa, if we think this Ka can be values very big, so 10 to the 6, for example, 10 to the 10, or really, really small. Because of that, we define a quantity called pKa. And pKa is negative log of Ka. That way, we will have a scale with the smaller numbers. Now we're going to learn in another video what is the pKa of some acid and bases, some acids, and use those values to predict the outcome here. Where is the equilibrium going? Is it product favor or is it reactant favor? So we're going to do that next.